Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW. Let the team at Black Hills Information Security test your defenses. With over 10 years of experience in penetration testing, red teaming, and threat hunting, the testers at Black Hills will help you find the holes in your security before the bad guys do. The team at Black Hills cares about educating and sharing their knowledge by creating countless blogs, open source tools, and webcasts for you to learn more about the tradecraft of pen testing and red teaming. Visit securityweekly.com/BHIS to join their mailing list and view the latest blogs and webcasts from Black Hills Information Security. The greatest threat to businesses today isn't the outsider trying to get in. It's the people you trust, the ones who already have the keys, your employees, contractors, and privileged users. 60% of online attacks are carried out by insiders. To stop these insider threats, you need to see what users are doing before an incident occurs. Observe-It enables security teams to detect risky user activity, investigate incidents in minutes, and effectively respond. Get your free trial at observeit.com/securityweekly. Welcome back, everyone, to Enterprise Security Weekly. If I talked about topics that were just interesting to me, we might talk a little about security, maybe some about hip-hop and headphones and stuff, but we want to talk about what's interesting to our listeners, not just what's interesting to me, and have advertisers that are of your interest as well, and not mattresses or meal services like a lot of other shows have. We want what's interesting to you in security. So if you want to have some input into that process, you can go to our website, securityweekly.com, fill out our annual listener feedback survey. We will anonymously collect your thoughts and take action on them, as we already have this year, based on last year's survey. Yep. So
I'm still working on it, actually, right?
Right.
First thing we did was the listener interest survey, start to categorize content, the new website, that content's now filtered and sortable by that. Now it's the member site to try to make it even easier to consume that content. So we're still working on last year's survey, but we definitely want to hear what our listeners want to see more of.
Our interview for this segment, we'd like to welcome Reuven Harrison. He's the CTO and co-founder of Tufin. He led all development efforts during the company's initial fast-paced growth period, and he's here today to talk about cloud containers and all such things, and microservices. Reuven, welcome to the show.
Hi.
Nice to have you for this chat. It's a topic we love talking about. How do we get our applications, well, first into containers and microservices, and then once you do so, how do you get them in the cloud? And then what about the security thing, right?
Yeah, and what about all those different layers in between?
Right. Yeah, we've seen Kubernetes, as you guys mentioned, kind of grow exponentially over the past 2 or 3 years, right? You can see it by the size of the KubeCon event. Every year it's growing. And now we're starting to see quite a lot of enterprises using it in production, which is where our traditional market is.
Yeah, it's interesting, right? I was describing this in the last segment. I think it was 3 years ago at KubeCon when Docker said, look, we're going to support Kubernetes as an orchestrator in Docker Enterprise. And to me, that was really where Swarm they put the fork in it and said, okay, Kubernetes is one. And that's changed the way people have architected their containerization environment, right? They were Docker Enterprise with Swarm. Swarm had a lot of great capabilities, but also some limited stuff that Kubernetes changed. Some very interesting decisions Google made as part of the open source project to do that. And what you saw was a lot of people who made a technology decision on going 100% in with Docker now going, whoa, I kind of revamp my architectures, and then you saw the shift over to Kubernetes. I'm curious, Reuven, one of the things I've heard from enterprises with Kubernetes and orchestrators in general is it's not that easy to build your own Kubernetes cluster, get it to scale and manage, right? You've got a bin packing issue with how many containers can you run on a cluster and all this other stuff. And then as you expand, how does that expansion happen in a kind of an automated way? And so what I was hearing a year or so ago, because with Layered Insight, I mean, we were in the middle of these discussions with enterprises, is people were struggling managing their own Kubernetes clusters. And then you see things like EKS and GKE and Fargate and all these other things start to spin up. I'm curious, how many people are still rolling their own? How many people are trying to figure out how to use these managed orchestration environments? And then how does Tufin actually help in those different kind of environments?
Awesome. Kubernetes isn't simple, right? There's a learning curve there, but developers, technologists love it. Once you get the basic notions of what is a pod, what is a service, what is ingress, what is a network policy, these kinds of basic things, which are complicated, and you have to manage them in YAML files, which is, a lot of people don't like YAML, but once you get these notions, you've had some experience with them, it's great because it simplifies so much of the traditional stack. So if traditionally you had like your VMs, and then you had your your load balancers and your firewalls and your routers and the code deployed on the VMs, all that complexity now just becomes Kubernetes, right? So the entire stack has moved to software with Kubernetes at the infrastructure, and that's great. That's a dream for developers, like having that standardization where you just put your software in a container and kind of create some YAML files and get it deployed automatically. But as you said, there's a lot of challenges running it operationally. It's not trivial. We use GKE, actually. I know you guys talked about it earlier on. We love it. We think Google Cloud is actually great for developers, and I think a lot of developers who use it love it as well. So we run our Kubernetes clusters on Google, and that works well for us. A lot of enterprises are using OpenShift, like you guys mentioned. OpenShift is a different story. It's Kubernetes, but it's not Kubernetes, right? It's something similar. And then you have EKS, AKS, and a lot of people running native Kubernetes on the cloud as well. So all these different flavors, there's a lot of permutations there. But again, as a developer, as a technologist, it's easy and it's great.
Right, it's great for developers, really easy. But now what we've done is we've given the developers, Paul, the opportunity to spin up traditional infrastructure that would have been IT's job, and then security would have gotten in the mix to say, I got to put these security controls in place. And I think this is where the interesting challenge is because we've given developers the ability to create these configuration files, spin up infrastructure like nobody's ever seen before. But is it secure infrastructure?
Yeah,
right? We've abstracted all that away.
Kind of a bad example is I've got a career in security, and I was a Unix sysadmin, and I was a network admin. So it's a logical place when I do development. I take all that in consideration because it's my background. But if you look at a traditional developer who's been trained in software engineering, and I think there's a huge difference between me as a programmer and an actual software engineer. I think you've got to make a lot of distinctions there, right? How do we get the software engineer to deploy applications in a secure environment that they're also defining?
Yes.
Yeah, that's a great question. And that's, I think, a question of business processes and ownerships, right? Developers their main task is to deliver functionality and deliver it as fast as they can, robust as they can, right? It's not securing the infrastructure. Now, a good developer will always keep in mind security. So he'll try to avoid the basic stuff, right? He won't put his secrets on GitHub. And if he will, he'll get an alert about that pretty quickly. Mm-hmm. He won't deploy vulnerable images into an environment. But he may deploy a non-vulnerable image, which 2 days later becomes vulnerable. So that's an issue, right? He may not deliberately overly expose his data like an S3 bucket or a pod or a service to the internet, but he may do it accidentally because he doesn't have the attention because he's focused on delivering functionality. So I think it comes down to responsibilities and separation of duties, and I think developers should be focused on functionality and delivering delivering functionality. And then there should be a security person involved who's either part of the DevOps team or maybe even part of the corporate security team who sets guidelines or guardrails. And as long as the developers are operating within these guardrails, it's okay.
Yeah, one of obviously one of the big up and coming terms that everybody uses is concept of DevSecOps, right? And some people put it at the beginning and whatever. But in order to do that, we really have to figure out how to integrate security into the pipeline, the continuous integration, continuous deployment pipeline. We have to make the data easily accessible to the developers and the DevOps teams in kind of their tooling to make sure that when a vulnerability or a misconfiguration or a whatever is identified, that it's really easy for them in their tool sets, in their process to fix it fast, right? We're starting to see some interesting stuff happen there, but I think we still have to do a better job on the security side to really figure out how to integrate our stuff into their tools and make this concept of DevSecOps actually work.
So that's a perfect question because that's what I've been doing over the past 2 years. So you probably heard of our new product called Tufin Orca, which is dedicated to security on Kubernetes platforms. So it runs on Kubernetes and it secures Kubernetes, which is great because we can eat our own dog food, right? But we've decided that we want to focus on building security into the CI/CD pipeline, right? DevSecOps. And what we see, the state of the art, is that almost everyone is doing, to one extent or another, vulnerability scans in the pipeline. Okay, that's pretty much a commodity now. You can do it in your Docker registry, whether it's Docker Hub or something else. You can embed that into your pipeline. That's easy. You can scan images as they get built, and we can do that as well as can probably 100 other solutions on the market, including open source and commercial, right? But it goes beyond that, I think, and this is where it gets really interesting, is that we think that application security or vol scans are really step one out of something much bigger that you can do. And we see an opportunity to use DevOps or CI/CD as a way to not only remove the friction between dev and security, which has traditionally been very problematic because dev wants to move fast, security wants to slow down. What we've done is we've said, let's take this practice of CI/CD and leverage it to align the objectives of developers and security. And what we've done here is we've said, what is the most important thing that a good developer does? He writes tests, right? Test-driven development. And that's something that a good developer will do independently of security teams. Let's take these tests and leverage them for security. That's what we've done. We basically, without going into too much detail, we use these tests to learn how the application is supposed to behave in a vanilla environment in the right way. And then we build a policy based on what we see, and we roll that out. We promote that policy to production with the new features. So we're doing security at the speed of the CI/CD, and we're aligning these tests within the CI/CD processes. That's pretty much, I think, the most exciting thing that I've been doing over the past 2 years.
And so if I understand that correctly, when a application coming in containers on a Kubernetes environment, you're kind of modeling what's happening in the environment with the application. Based on that observed behavior, you're starting to build a set of rules that you can now enforce, I assume, at the Kubernetes layer. Is that where the kind of the focus is?
Yeah, so you described it much better than I did. Thank you. That's exactly what we're doing. And then once we learn the behavior, we have rules, right? Rules that describe the proper behavior of the application. Now, we can obviously use native controls in Kubernetes that are pretty good. So we have the network security or the network policies, right? Mm-hmm. Which people don't use because they're just too complicated to operate manually. And then this automated discovery makes it much easier. And then you can also extend it to other controls, because once you know what the application is doing, and obviously Tufin, we have the ability to control firewalls and cloud platforms and other stuff. So we can extend that to the underlying layers. So we can do layered security, which is even nicer. And we can enforce it at the Kubernetes level to do microsegmentation, at the firewall, which might be sitting in front of the cluster or between the cluster and an on-prem database, for example. So yeah, we can extend that nicely across the hybrid network.
Yeah, I mean,
one thing, sorry, Matt. One thing I've observed along these lines is that when you're implementing your application and you're building the environment and your application basically at the same time, right? Regardless of what technology it is, and some are worse than others, it feels to me like when I was coding in Perl, right? Like there's like 12 plus ways to accomplish the same goal. Now, the differences between those 12 different ways are some do security, some don't do any security, some are more resilient and easier to maintain, and some aren't. But all these examples are out there. What guidance do you have for us, Reuven, as to how we can standardize and give developers, which is, I think, a big reason why we have security exposures in these environments, give developers a really good foundation and blueprint for, if you're this technology, here's the best way to implement it that is the most ubiquitous in terms of security and architecture.
Okay, so in favor of being very practical and focused, I'm gonna mention 5 things that you should be doing to secure your Kubernetes clusters. So first of all, you want to do network policies. You want to reduce the attack surface as much as possible. So don't expose anything to ingress that doesn't necessarily need ingress access. Don't allow egress that doesn't need to be there. Don't allow namespaces to talk to other namespaces that shouldn't have that connectivity. Okay, so these are typical examples. Write your policies. They're, once they're out there, it's easy. They'll protect you. It's a good practice. Secondly, RBAC, role-based access control, right? Not everyone needs access to the API server in Kubernetes. So first of all, services and pods that don't need access to the API server, just don't allow them to even talk to that service. And then for the ones that do need access, put some RBAC in place. Don't allow them to do anything. Limit their ability to perform queries or REST APIs on the API server. Then the new big feature that's coming up in Kubernetes, which is now with 1.16 has become has got its own policy / API URL, is the pod security policies, the PSP. That's another one that's easy to put in place. Just don't allow containers to run in privilege mode, and use SE Linux, which everyone's been talking about SE Linux for 15 years, but nobody's been able to do it. And now Kubernetes allows you, kind of gives you that standard API to do that. So use that. Limit what pods can do. That's going to be great. And the last 2 are vulnerabilities. Okay, so image vulnerabilities for sure. Vulnerabilities are found every day. A pod, an image that was perfect, no vulnerabilities yesterday may be really bad today. So do the ongoing scans in the CI/CD pipeline, do them in production as well in runtime. And last but not least is platform vulnerabilities. So you want to do make sure that your Kubernetes cluster itself is not vulnerable, because a lot of vulnerabilities have been discovered recently. So you need to upgrade and patch that. And also the underlying cloud infrastructure, right? So just make sure your infrastructure is properly secure.
So it sounds like, Reuven, when we design applications to go into this environment, that we need to maybe spend a little more time planning and designing our applications so that we have more details, so that when we get to this phase, we can actually define all of those things, which I think is a good thing.
But you know what? I agree it's a good thing, but it's very difficult to do. And this is probably the number one problem that we see in security, not only in Kubernetes, but in every type of enterprise security. The number one problem is that you put a policy in place, the next day everything's changed, right? The applications they have new behaviors. The infrastructure has changed. Somebody has upgraded something, the storage is now over there, and somebody's changed the network from one vendor to another vendor or a firewall. These things make it pretty impossible to keep up. And what happens is people just leave their policies overly exposed because they don't want to disrupt business.
Yeah.
And what we're saying is always the same thing. You need to automate the ability to create these policies. If you're just creating them manually, by definition, you won't be able to do a good security policy.
Mm-hmm. This is a great opportunity for security, though, is to learn from some of the mistakes that we've made in the early days of implementing containers in Kubernetes, because I feel like a lot of people have made these fundamental mistakes and create guidelines and a framework that when you go deploy new applications, here are the things that you have to include in terms of controls inside of your application and architecture, so that when you're deploying it, it's not 100% secure, right? But it's 90% of the way there, just inherent based on the way you're going to design it.
I mean, Reuven, you pointed out one I've been on a mission for years, which is don't give up root. Why would you give up root in a container?
I made that mistake.
Yeah, he made that mistake.
I did that.
But there are security solutions out there that require root access as a privileged container to actually do security. It just completely defeats the purpose of it in the first place.
Right. So this is really interesting, and this is something that we very recently occurred. So within our team that's innovating this new this whole Kubernetes security, we realized exactly what you said. That all of the security solutions in Kubernetes, I think all of the ones that you mentioned in the previous show and the ones that I'm aware of anyway, they all require root access, right? Because they're doing security, so they need that access, which is counterintuitive and probably also risky. So one idea that we're playing with, and I'm not confident enough to say that it's a good idea, but perhaps the listeners may have some feedback, is really you shouldn't be running any privileged security workloads in production. What you should do is you should run them in staging. You should use them to create the native policy definitions, like the ones I mentioned, like the network policies, the RBAC, the PSPs, and stuff like that. And then take the output of that and promote it to production without the security workloads. Okay, so security workloads should only be in staging; they should never be in production. That's something that I would really like to hear some feedback about.
I mean, that's an interesting concept, right? In the early days of containerization, in Swarm that didn't allow privileged containers, but Kubernetes did. This is one of those big decision points that Google made. And I've talked to the Google guys about this and the impacts of that decision, by the way. You saw a lot of people go after these privileged container aspects. And so I agree with you in that now that Kubernetes has matured over the past 3 years and provided native capabilities, what these tools really need to look at is leveraging the existing capabilities in Kubernetes and use that capability without giving up root privileges to secure the environment. That is one way to do it. The way Layered Insight did it is we actually embedded some capabilities inside the container running as user, not as root, which is another way. But that's much more difficult, by the way. Trust me, having worked on that product for a couple of years, the challenges with that. But Kubernetes has made it easier to enforce policies in production. And if you can truly leverage your tools to create those policies and use the native stuff, you're going to be more secure than using one of these privileged root level access capabilities.
So thank you. I totally agree with that. And then we'll see how this evolves. I think a lot of Kubernetes users are not really doing security yet. It's beginning. We'll see more of that. But I totally agree with your last statement.
Because they're all figuring out the bin packing issue and how big of a cluster do they need to run all these containers. That's why.
Yeah, exactly.
So, Reuven, if I'm the security person and I've got multiple teams, they're doing implementing a DevOps process, and I come to Tufin, what's the story that you tell me of how I can gain some visibility and controls into the environment that's cranking out applications and doing multiple pushes to production a day?
Yeah. So first of all, the Orca solution, which knows how to deal with any type of Kubernetes, including OpenShift. So that will look at your application behavior, as I said, and learn it, create policies. You can promote them to production in the CI/CD pipeline, which is very advanced, right? Maybe born in the cloud startups and companies can do that, but most enterprises are not there yet. They like the concept, but they're not able to do it yet. Enterprises are still building Kubernetes as part of a much larger and hybrid network, right? So they have maybe some private cloud, public cloud, firewalls, and then they need to kind of create this unified policy across that hybrid environment. So it's a different kind of challenge, but again, Kubernetes is playing a bigger and bigger role there. So I would say the following: it's a maturity model, right? Like it always is. It depends where you are in your maturity. Now, if you're just beginning with Kubernetes, then do something basic, right? Do some RBAC, do some maybe basic network policies at the namespace level. Always keep in mind CI/CD automation. Always automate, right? That's what a good DevOps team does. So try to build as much of that into the CI/CD process as you can. But if you're a larger company, larger enterprise with many teams across different environments and platforms, then maybe think of it as a business process. Don't think of it as a Kubernetes cluster, right? Start building the processes. How are you going to teach your DevOps teams to know the basic security principles? How are you going to make them comply with your basic requirements? How are you going to define the guardrails and stuff like that? But that's a high-level thought about some guidelines for people who want to do security.
Outstanding. Reuven, thank you so much for appearing on Enterprise Security Weekly. For folks that want to learn more, you can go to securityweekly.com/Tufin. Thank you so much.
Thank you.
With that, we'll take a short break and come back. We're going to be talking with Sysdig coming up next, continuing our theme on Kubernetes security.